need your love. You got that hold over me. Long as I got your love, you know that I'll never leave. When I wanted you to share my life, I had no doubt in my mind. And it's been you, woman, right down the line. I know how much I lean on you, only you can see the changes that I've been through, have left a mark on me. You've been as constant as a northern star, the brightest light that shines. It's been you, woman, right down the line. I just wanna say this is my way of telling you everything I could never say before. Yeah, this is my way of telling you that every day I'm loving you so much, mama, 'cause you believed in me through my darkest night. But something better inside of me, you brought me into the light. Threw away all those crazy dreams, I put them all behind. And it was you, woman, right down the line. I just wanna say this is my way of telling you everything I could never say before.
In this unit, we are going to finish up, or I should say in this video, we are going to finish up this unit. It may be a little longer video, depends on how rambling I am during the video, but we are going to finish up the unit in this with this video. We are going to start by talking about anchorage points. Remember, with the PFAS personal fall arrest system, we have the harness, lanyard, or other connector, and we have the anchorage. This is what the lanyard will connect to. It needs to be structurally sound. There are thresholds that have to be met for the strength of this connection point, of the anchorage point, which we'll talk about. So let's go ahead and get started. Lanyard connection point, 5,000 pounds. It has to be able to support 5,000 pounds of weight, or be designed by a registered professional engineer. If it's designed by a registered professional engineer, it's a certified anchorage point, and it only needs to support 3,600 pounds. Overhead anchorage points are the best. Overhead anchorage points will reduce our fall distance. Like we talked about in the previous video, if we tie off at our feet with a 6-foot lanyard, the fall distance is going to be at least 10-12 feet. And you really should, if it's less than 18 feet, you should not use a standard 6-foot lanyard, because if it's less than 18 feet with a standard 6-foot straight lanyard, there's a good chance the worker is going to make contact with the lower level. And that's what this point here is about. Anchorage position and lanyard length must be configured to prevent contact with the lower level or objects on a lower level. Another concern we have with our anchorage points, even if it's overhead, is the potential for swing fall. If the anchorage point is not directly overhead, the worker will swing, and they may swing into objects with enough force to cause injuries. Now, self-retracting lifelines, retractables. Remember, SRL is another term for a retractable lanyard. They're going to be more susceptible to swing fall because you can get them extended out further. Some self-retracting lifelines, you can pull 20 feet of cable out of the case. And if you got 20 feet of cable pulled out of the case and it's not directly overhead, well, you're going to have a long way to swing. And we have illustrated here what we are really getting at with swing fall. Here's the anchorage point. He's using an SRL. Let's say he's got 10 feet of cable pulled out of that SRL case. When he falls, he's going to fall right back into that wall. He's not going to stop swinging until he hits something or until his momentum is naturally dissipated. So, doesn't have to be directly overhead, but the closer it is to overhead, the better. It should be overhead, but we got to pay attention to swing fall when we are doing training, when we are observing workers in the workplace. It needs to be on our radar. And here is some information from 1926-502, the construction standard on fall protection that deals specifically with anchorage points. 5,000 pounds for every person tied off to it. Here are some of the different devices that are available. This is a disposable cross-arm anchorage strap used with concrete forms. They are attached to the forms, and they stay in the form even after the concrete is poured. They're wrapped in around the rebar or a part of the form. Concrete's poured over them. They remain in place. They do provide an anchorage point, a tie-off point for workers who are working on the forms. And I just used the term tie-off point. That's a commonly used term for anchorage point. You'll hear workers aren't going to say, well, I've got a great anchorage point over here. Or you're going to hear one worker ask another, they're not going to ask, where are you anchoring off to? They're going to ask, where are you tying off to? Where should I tie off to? I'm tying off to this point, or I'm tying off to that point. Anchorage points in the field are normally going to be referred to as tie-off points. This is a type of tie-off or anchorage point that is designed to be used with a device called a cable grab or a vertical lifeline. A vertical lifeline is a vertical cable that will have a device like this attached to it. The worker will attach their lanyard to this ring. If they fall, this has a braking mechanism built into it that will grab that cable and decrease the distance they are going to fall. There are also rope grab devices along the same lines, the same rationale. A rope grab, cable grab, same types of devices, just slightly different pieces of equipment, slightly different materials. This is a permanent anchorage point that might be epoxied into a concrete surface or other structurally sound surface. Again, it has to be structurally sound. If you attach this to something that's not built correctly, it's not going to support the weight of the worker. And again, must support 5,000 pounds for every person tied off to it. This is a cross-arm cable, not disposable. It's like the disposable cross-arm strap we have over here, but it's a cross-arm strap made out of wire rope material. You throw this over a beam. Again, the beam has to be structurally stable. If the beam's structurally stable, you throw this over that beam, choke it to that beam, and the worker's going to connect their lanyard right here. This is a reusable concrete anchor. You drill a hole into concrete, and that hole provides a compression fitting with this device. They put this device into that hole. Once it's into the hole securely, it can't be pulled from that hole. easily. It does provide the required anchorage support. Use these a lot in a lot of different construction projects. They're nice because they are reusable. They are expensive. So if you use these devices, make sure your workers understand that they are reusable, and they need to return these devices to the tool trailer when they are finished using these devices as an anchorage point. Again, they are expensive. And I've seen a lot of them lost on job sites because workers don't understand that they're reusable, and they don't understand always how expensive they are. So, but be nice, be nice, but let the workers know that, hey, we need to get these back in the tool trailer when we're done with them. This is a rolling beam anchor, also referred to as a beam trolley. You'll see a lot of these devices in ironwork. If you have a worker walking on a girder or a beam, they're walking here. Let's say this is their walking surface, and there's another beam above. The beam trolley will go on the beam above them, and the worker will connect to that ring right there. It rolls back and forth on the girder and allows pretty good range of movement for the worker. Handy little device. Again, not cheap. I have in my collection of fall protection gear, I have a similar device that it doesn't have the rollers on it, but it functions the same way. This is an anchorage cart device designed for one person to tie off to. Now with this, you don't have to drill any holes. You don't have to fill it with water. But when you lay down these outriggers on a flat surface, like a concrete surface, it forms a connection to that surface, and these outriggers especially keep it from sliding and moving. It's got pretty good weight to it. The weight of the device, along with these outriggers that grab onto the surface that it's sitting on, it will provide anchorage for one man or for one worker. And the worker, they will hook their lanyard to that ring right there. Here's a cross-arm strap made with chain, similar to this cross-arm strap, same concept. Here is a 6-person anchorage cart. Now this one is different. You put water or sand, you put weight in this, you put counterweight in this. Then you also have stabilizers that are deployed. You put the weight in it, you deploy the stabilizers, and you see 1, 2, 3, 4, 5, 6 rings that workers can tie back to. We use both of these devices a lot in bridge work, because once you pour your bridge deck, the owner doesn't want you drilling holes in the bridge deck. But you have to have something to tie off to in some instances. So we would use carts like this to provide tie-off points to the workers. And another cross-arm strap. And this is a good picture here because it shows how the strap is choked around the beam and providing the tie-off point for the worker's lanyard. And I could do 30 minutes just talking about all the different possible devices that are out there. There's tons of devices available. And going back to my point I've made a couple of times now, there's never an excuse for not having a tie-off point, not having fall protection for your workers. And I've mentioned this, but let me reiterate. Whatever we're using our cross-arm straps with, or let's say we're using a permanent anchor, we need to make sure that what the permanent anchor or the cross-arm strap is attached to has the structural integrity necessary to support the worker in the case of a fall. In this photo, we have an example of a couple of different things. First of all, the good thing that we see here are the workers that are tied off to the horizontal lifeline, which I'll talk more about. We also see on the tops of these girders, we see some bolts or studs sticking out of the tops of these girders. These bolts, these studs are called Nelson studs or anchor bolts, and they help the concrete bridge deck to attach securely to the girder structure of the bridge. It's part of what ties the deck and the supporting structure together. These are not good anchorage points. And if some of you are thinking, well, duh, it's not a good anchorage point. It's not a positive connection. It doesn't provide a positive connection. But the reason I mention this is because workers do try to use these Nelson studs as anchor points. When I was with Manhattan Construction, it was outside of my region, out of the Oklahoma City region, but a worker tried to connect to the Nelson stud and use the Nelson stud as an anchorage point. Had his harness on, he had his lanyard, and he was going to use this as the anchorage point. That was fine until he fell. When he fell, the rebar hook that he was using that was on his lanyard popped right off the Nelson stud, and he fell 30 feet. The upside of that whole incident, workers learned immediately that you can't use a Nelson stud as an anchorage point, as a tie-off. And the other upside, the worker survived. Even though he fell on rocks below, he walked away from that incident with only a broken arm. And there's more to that story with that worker. He did survive the fall. If anybody wants to hear the rest of the story about that particular worker, I'd be more than happy to share it with you. But again, I do want to try to keep this within 50 minutes, this particular video. And we have the horizontal lifeline anchorage here, which is good. All these workers are tied off to it. They're doing great. And what they're doing here, I should mention, is they're setting spanholes. On top of the spanholes, they'll lay plywood. Once the plywood's down, they do the rebar, the reinforcing steel, then they'll pour concrete, which I talked about in a previous video. The horizontal lifeline anchorage is a common tie-off device or tie-off point that you'll see in a lot of different work environments. It is exactly what it says it is. It's a horizontal line that is structurally secured at each end. It will have intermediate posts that will help maintain the proper elevation of the line. If it's set up correctly, it provides an excellent tie-off point and allows good worker movement. They're not too constrained when they're tied off to the horizontal lifeline. But it must be installed by a qualified person who has knowledge and experience. They know what they're doing. I can't have the new guy go out, and I can't tell the new guy to go out and put up the horizontal lifeline. It has to be someone with experience, knowledge, skill necessary to do it right so that the anchorage is safe. Must be installed according to design specifications. There should be a design. It shouldn't be, well, let's try this. We got all these poles, we got this cable, let's put this together. There should be plans showing how it goes together. And I'll give you an example of what we mean by plans on the next slide. The plans and specifications must be readily available. They don't have to be on the job site or in the factory. But if, let's say, OSHA shows up and they request the plans, they want to see the plans, you need to be able to get those plans, the specifications, to that inspector. The plan specifications must identify the line capacity, the maximum number of personnel that can be tied off to the line at one time. Companies need to make sure that this line capacity is not exceeded. Another issue with installation of a horizontal lifeline is the amount of sag in the line. Common sense may cause us to think that the tighter the line, the better. That's not true. Your line needs to have a little bit of sag in it. That sag helps with shock absorption. If the line is as tight as possible, it doesn't provide any shock absorption. It's going to result in more force on the worker when they fall, and also more force on the line itself when a fall occurs. So a little bit of sag is good. Sag must be taken into consideration during design, installation, and maintenance. If you are using wire rope clips at each end of the horizontal lifeline, you must use at least 3 wire rope clips. And I'll show you some pictures of what we mean by terminations and wire rope clips. We need to also consider the height of the lifeline. That's not specified anywhere in any of the ANSI requirements. It's not specified in OSHA as far as how high the line should be. But best practice is going to be shoulder head height. It's going to limit fall distance if it's at shoulder or head height. It's also going to make it easier for workers to go from one side to the other. They're not going to have to step over it or crawl under it. Let me go back to this line, this picture. This was a store-bought horizontal lifeline system. Thousands of dollars were spent on it. It was too low. It's right at just a little below the waist of the workers, and these are short guys. This is a very low line. This worker, to get over here, he has to crawl under it or crawl over it. Not good. If the line was up here, he wouldn't have those obstacles to getting from here to here. Also, if the line's up here and he does fall, that's going to limit his fall distance. If he is tied off here and he falls, he's going to fall a couple of extra feet before that lifeline catches him. So height of lifeline needs to be taken into consideration. I prefer shoulder head height in that range. You do have to take into consideration the size of your average worker. If you put it too high, they're not going to be able to reach it. And you do run into that with a lot of construction crews. Like I mentioned previously, construction workers typically are smaller. They're not the stereotypical big guy. They're pretty small. They're small, wiry, hard workers, strong as an ox, but they're not big. And this is what we mean by the plans. Having some written drawings, some plans for your horizontal lifeline. Now this is for a special type of horizontal lifeline that we used on pier caps at the company I worked for in the past. And it shows the termination of the line at each end. And it shows a clear span of horizontal lifeline. And all this detail here shows how it's attached to the pier cap and so on. We don't need to go into those details, but when you're working as a safety manager, assuming you're using a horizontal lifeline, the plans like this need to be available. And when the line's being installed, the plans need to be followed. And here are the installation instructions right here. All designed by our engineer. Stuart Ronald was the registered professional engineer that signed off on this. Myself, working with another engineer, we came up with the design. Another engineer named Gerry. He gets most of the credit. It was my original idea to have a line like this across the top of the pier cap. He did all the math. He did all the drawings and all of this. And then once we developed this line, once he designed it, we then tested it. we had a facility where we would test our lifelines, and ended up being a great little system. But you can see here, this I don't remember this worker's name. Hard worker, great guy, love him to death. But he's a shorter guy, and you see how the height of this line, his lanyards are just barely reaching up to it where he's standing. But if he falls, he's only going to fall. He's going to fall less than a foot, which is going to be good for him as far as the forces on his body. Notice he's using a twin leg lanyard. So is this gentleman here, a twin leg lanyard. Now here he's using a shock absorbing straight lanyard. This worker is using a twin leg retractable lanyard. But having the line up here reduces their fall distance. Before we developed this line, workers would tie off to a static line that was strung across the top of the pier cap. Static line across the top of the pier cap, that increased their fall distance. It wasn't as good for the worker. It wasn't as safe for the worker. Let's see, what else do I have here? Again, if you design in-house, engineers need to be involved. You need to test the system. You need to test the system according to the ANSI and OSHA protocols for testing horizontal lifelines. And the main consideration there is your test weight. You have to have a 220-pound test weight for testing these devices. And we were using load cells to determine the force generated by that 220-pound weight. We spent a day conducting different kinds of tests, and we were very pleased with the stability of the system. Now, I don't know if this company's still using the system. Myself and Gerry were both gone. We were the big proponents of this. Wouldn't surprise me at all if they're not using it anymore. But it is a good system. Works, made it safer for the workers. Now, once we have the lifeline up, it needs to be inspected before anybody ties off to it, and then at least daily by a competent person. A competent person is a qualified person who has the authority to take corrective action. That is an OSHA term. Qualified, meaning they have the skills, the training, the knowledge to know what's safe and what's not safe, and they have the authority to take corrective action. A competent person is a person who can say, this isn't right, everybody stop, we're going to fix it. If they don't have the authority to shut down the job, they're not a competent person. And that authority comes from the employer. The employer designates who the competent person is in different work environments. Some things to look for in the inspections: proper end terminations, the post supports, the cable itself. The cable that we use, the wire rope that's used, can become frayed. It can become worn. Any of the hardware that is used in the lifeline assembly needs to be inspected. Hardware like turnbuckles that are used to maintain the proper tension in the line. Chains, if chains are used in the assembly installation of the system. Here is an example of a poor design and a poor installation. This design required support cables to hold the posts up. That's not a good design. It was scrapped pretty quickly. Gerry and I, again, working together, said this isn't right. We need to come up with something different. And we scrapped this system, and it was replaced by a system that would attach to the girders without the need for the support cables. Here is an end termination that only has one wire rope clip. Very common. If you're using wire rope clips to terminate your lifeline, it's real common for workers to take a shortcut. And so that's something to look for. You need at least 3 at each end termination. Depending on the size of your wire rope, thicker wire rope may need more wire rope clips. And wire rope clips are pieces of hardware that allow you to make connections between the wire rope and another structure or different sections of wire rope. Here we have a splice in wire rope using wire rope clips, but this splice is not good. They should have at least 6 wire rope clips. They only have 2. And they don't have enough overlap between other 2 sections. The better way to form a splice and wire rope is to create interlocking loops. We have an interlocking loop here with 3 wire rope clips, interlocking loop here with 3 wire rope clips. The interlock of the loops, that's much better than the splice. If you do splice, you have to follow the guidelines that are specified for splicing wire rope. You have to have significant overlap between the 2 pieces, between the 2 sections, and you have to use the right number of wire rope clips. The minimum for an overlapping splice like this would be 6. It could be more depending on the splice itself and the characteristics of the wire rope. So pay attention to these issues if you're working around horizontal lifelines. Now, the better horizontal lifelines, they don't use wire rope clips. They'll use other hardware to make those end terminations. In this picture, we are using a come-along as a lifeline. The come-along is attached to the rebar cage. The worker's tied off. They think they're doing a great job. And again, I didn't beat them up over this. They were being innovative. They came up with a way to protect the worker that had to get up here. They needed to put a worker up on top of this portion of the rebar assembly, and I'm sure the superintendent thought, well, Doug will be pissed off if we're not tied off. So they strung the come-along cable across from one column to another column. And again, I didn't beat them up over it, but this is not tested. This is not necessarily going to withstand the force generated by a falling worker. It's a great idea, but we don't know the force, and we don't know if that rebar cage, how it's going to react if this worker falls. Because the forces generated in a fall, from our calculations, they can be substantial. This worker falls, the come-along could fail, or the rebar cage could fall over. There are instances every year in the United States where rebar towers like this fall over under their own weight. And if you add the additional force of a falling person, that could definitely pull one over. So there could be a way to do this, to have a lifeline that meets OSHA standards and also protects the workers. First of all, you need an engineer involved, not just your regular safety professional, engineer involved to do the calculations and make sure this is going to support the weight of a falling worker. Once you have that knowledge, then you can use a device like this that is designed for that application. It's called an easy line. You have one end attached to one structure, the other, it's retractable. You pull out the cable, the other end of the cable attaches to another structure. It can be set up and provide a tie-off point for up to 2 workers with a maximum span of 40 feet. And that would have been perfect in this circumstance here, because the other tower is just right out of the picture here. I think 40 feet would have been plenty for the span that we're working with. Really good device, not cheap. Not cheap. I keep talking about how there's all this equipment out there available. a lot of it's pretty expensive. But I say it's expensive, but in many cases it's going to be less expensive than an OSHA fine, certainly less expensive than the cost of a serious injury because somebody fell. Another work environment or task that we need to talk about when it comes to fall protection is working on tops of vehicles, fall protection on vehicles. This is a hazard that gets overlooked in a lot of circumstances, and it gets overlooked because OSHA does not generally cite companies for lack of fall protection when working on vehicles or equipment. But if you fall off of a crane, or you fall off of a tank, you fall off of the cab of a bulldozer, that's going to hurt just as much as if you fall off a bridge, a scaffold, or a ladder. That should be our standard. If somebody falls, are they going to get hurt? That should be what determines whether we provide fall protection or not whether OSHA is going to write us a citation or not. There are methods for providing fall protection on vehicles. We've got methods. People are going to be hurt if they fall, so we need to do what we can with the methods that are available. And on the picture here are a couple of examples of methods or devices that can be used to provide fall protection on vehicles. Let's say we have this chiller unit on the back of a trailer, and a worker needs to get up on top of the chiller unit. You can use a portable overhead anchorage like we have here. It's on wheels, it rolls around, it's got outriggers and counterweights on it to stabilize it. You set it up quickly, the worker ties off on the ground using a retractable lifeline. The cable is pulled down. You can see the cable here, it's attached right there at the corner. The worker can take the connector, attach it to their harness, and then climb up on top and have fall protection the whole way. While they're climbing up, while they're up there, and while they're coming down. It's not that expensive, these systems. Now this one is a little more expensive. It's a unique kind of system. It's designed for smooth metal surfaces like tanks or aircraft fuselages. It's a vacuum anchorage system that uses vacuum pressure to attach to whatever surface it's on. Works very well. It sucks down onto the surface of a tank or a fuselage, and it provides an anchorage point, a secure anchorage point. The only downside, last I looked, these are about $15,000 for one unit. Another upside of the unit, though, if you have two of them, you can string a static line between the two devices, and you can tie. If you have two devices and a static line between them, you can put two people on that static line. And great innovation. It was originally developed, I believe, for the aviation industry. Workers needed to get up on top of aircraft, up on the fuselage. You can't drill a hole. They needed something. And this is the innovation that was developed to meet that need. Here is another portable anchorage cart or portable anchorage device. Not a cart. With this device, the vehicle provides the stability. It parks so that a tire is on top of a part of the device itself, and the weight of the vehicle provides the stability. Once the vehicle's there, it's stable, the worker can get up on top of the vehicle and have fall protection. Now I would add, let me go back to this other one. This device here could be used not just with vehicles, getting on tops of vehicles. It could be used around a lot of different types of work facilities if you needed an overhead anchorage and one wasn't available. This one moves around very easily. This one over here doesn't move around so easily. It's really only going to be used with vehicles. It's not on wheels, and it does require the weight of the vehicle to provide the counterweight to keep the thing from falling over. Now this system, last I looked, was only $9,000. That doesn't include the retractable lanyard. That's just for the frame itself. $9,000 is less than an OSHA fine, much less than the cost of an injury. Yeah, but this is kind of a issue for me, because I've heard it over the years. Well, there's no way to provide fall protection when we're up on top of that crane, or when we're up on top of the concrete truck. Well, there is. You just gotta be willing to make the investment in money and time to provide the fall protection. I do have a couple of videos here. I think we're getting a little long, though. If you would like the URLs for these videos, let me know and I will email you the URLs. These are overhead anchorage systems. The tether track system and the swing arm tether track, these are indoor systems that you would see in a warehouse or a manufacturing facility. But it's the same concept. It provides an overhead anchorage point. Now, these generally are going to be more along the lines of a permanent installation than portable like we have here. But there would be some portability depending on the model of the device. But if you want the URL, let me know. The main takeaway I want you to have from this part of the discussion is that there is a way. Don't walk away, there's no way we can do it. Well, that's just lazy. That's lazy and cheap. There is a way if there's a will when it comes to fall protection. Now, here's another example of how fall protection can be provided on vehicles. Now, this is a permanent drive-by work platform. You pull the truck up alongside this permanent platform, and then workers can work out of this basket and do whatever they need to do to the truck. If you're familiar with this area in the Muskogee Turnpike, there's at least one of these drive-by work platforms on the Muskogee Turnpike between Muskogee and Tulsa. And the salt and sand trucks that are used to treat the roads in the winter, they can pull up alongside this platform, and the mechanics or whoever can do whatever needs to be done to those trucks and be safe. They don't have to climb around on the outside of the truck. They can be much safer working out of the platform. All right, let's shift gears just a little bit and talk about a rescue plan for retrieving workers. And what we mean here is a plan for retrieving workers who are hanging in a harness. Permanent injury can occur in less than 15 minutes. Hanging in a harness can and has resulted in death. It's a serious issue, and a lot of companies they have the fall protection, but they don't have the rescue plan. Some things you can do or you can have in your rescue plan would be a man lift. Just having a man lift on site with sufficient reach. Using self-rescue lanyards. Self-rescue lanyards, and we will look at this video, can be purchased with lengths up to 100 feet. You can also have assisted rescues where other workers pull them up, but there needs to be a written procedure for this, and the employees need training. If you're depending in your plan on other workers to rescue the fallen worker, you can't just say, well, Joe will help Sam. Well, Joe might help Sam, but Joe might fall too. So you need to make sure that I's are dotted and T's are crossed, that there's a procedure in place, and ideally there's going to be a drill and practice that goes along with that procedure. They should practice the procedure before they actually have to use it. But let's go ahead and look at what we mean by a self-rescue retractable lanyard. Up to 100 feet. Most of them aren't going to be 100 feet, but you can purchase them up to that length. They're really expensive, but if you need them, you need them.
You want to know what happened to him? He went to work this morning, put on his hard hat, got all rigged up, working on a high-rise. He's on the 23rd floor, works all day. All of a sudden, lunchtime comes around. His coworkers go to lunch. He decides to stay back and take a selfie from the 23rd floor. But unfortunately, he wasn't paying attention, so he fell off the edge and is now hanging there. No one's around. What is he gonna do? What are you gonna do, Steve?
Take another selfie.
You are not. What are you gonna do, Steve?
Facebook Live this.
Okay, after you selfie, after you Facebook Live and Instagram and Snapchat and tweet, before your legs go numb, Steve, what are you gonna do?
Well, hopefully my employer that got me working in Heights has a fall protection plan or a rescue plan in place. One of the first things that I want to make sure that, man, if I have these suspension trauma straps on my harness, I can actually kind of relieve that pain and uncomfortable feeling in my leg. So that's what I've deployed first. But the employer, they can do something like as simple as a rescue ladder, lower it down to me, and then I can climb back up. But unfortunately, rescue ladders are a little difficult to climb, and then it also puts somebody out at risk. If they incorporate a 3M DVI solid self-rescue device onto the harness, which is one of the simplest things to do, comes in 50 or 100-foot lengths, or the training unit, it actually turns the rescue right over to me. So I can perform my own rescue. It goes on about any harness there on the market, and so it makes it convenient. We'd love to have people in 3M harnesses, but not necessarily the case. But in the event they fall, I have the 3M DVI solid self-rescue device. I open up the pouch, which exposes my ripcord here, and I'll give it a little pull. Well, I want to make sure that it's safe for me below, but then I give it a little pull, and I descend to ground all on my own. So I don't have to worry about anybody else going up at the height.
Yeah, the self-rescue lanyards allow a controlled descent to the ground, up to 100 feet. Again, expensive, but I was never able to convince any of my companies that we should invest in those because of the expense. But I really have a lot I really think they're a good idea, and they can potentially save company money. But at the same time, in my industry, we always had man lifts on site. The man lift is going to be the best way to go. But sometimes you might have man lifts that aren't tall enough. If you end up on a 150-foot tall bridge and your man lift only goes to 120 feet, then you really don't have a rescue plan. All that needs to be taken into consideration. We plan for safety. Going back to Military Standard 882, it's about the hazard analysis, the risk assessment, and the planning. And part of the planning, if you're working up in the air, is having a rescue plan for workers who may be hanging in a harness. If you don't have a rescue plan, we can have workers who develop suspension trauma, also referred to as orthostatic intolerance, where there can be severe damage to the body. And here is the regulation requiring employers to have site-specific plans in place, a plan in place. And that site-specific is really important. The plan that you had on one project, you can't just flip that plan and use it on another project because the environment's different. It needs to be site-specific. Each plan needs to be developed for that site, taking into considerations the characteristics of that site. And I think we've pretty much talked about this, but there's one more thing I want to show you. This was a job in South America, don't remember how many years ago. There were several workers up on top of a bridge structure. The entire structure that they were standing on collapsed. They were attached to lifelines. But when that bridge structure collapsed, it left workers hanging. And it's amazing how many workers were hanging on the one horizontal lifeline. Here they are. Again, this structure collapsed. These workers are hanging. Got to get them down. There was one worker who wasn't tied off, evidently, and he's over here on the shoring structure, climbing his way out. And there may be others in there, but the main focus here is on that cluster of men hanging together there. Again, failure of shoring tower, which supported the false work, men on false work when it collapsed. And here's some of the collapsed shoring and false work over here. And these are the men that were standing on it. Thank goodness they were tied off. There would have been multiple fatalities. This guy's lucky. He wasn't tied off, but he was still able to escape injury or escape serious injury. But here's a close-up of what we're looking at here. Cluster of men. And they're all hanging there, and we got to get them down. We got just a few minutes to get them down. Let's see how many we got. I've counted them before. 1, 2, 3, 4, 5, 6. There's at least 6 there, maybe 7 guys. Yeah, keep in mind, most horizontal lifelines are not going to be rated for more than 2 people at a time. So that was a very well-constructed horizontal lifeline that they're hanging from. How did they get them down, though? They didn't have man lift on site. They did come up with a plan. They used an excavator. Thank goodness they had an excavator with a long enough boom on it that they could get that bucket up in the air and bring them down that way. Not necessarily best practice, but you got to get them down. You can't leave them hanging up there until you bring in a man lift from 2 hours away. You got to get them down. And if I were in this circumstance and I didn't have a man lift, I'm going to use the excavator too, because the danger of them being left hanging in the air like that and what it can do to their bodies, how it can cut off their circulation and cause serious damage, even fatality. But hopefully, if I'm involved with the project, we got a plan in place, and there will be a man lift with enough reach to get up there to them. There'll definitely be a plan if I'm involved in the project. And if you're involved with a project like this, make sure there's a rescue plan in place. Oh, and in some instances, the rescue plan might be as simple as calling the fire department. If your project is within, let's say, 10 minutes of a fire station that has a ladder truck, that's maybe not best practice, but that's a workable solution as far as having a rescue plan in place. Again, 10 minutes is kind of long to be hanging. You really want to get them down sooner if you can. All right. We're getting close to the end. A few more things I want to talk about. Just some things for you to think about, because most of you are going to go in and work as safety managers. And you will have, as part of your responsibility, equipment management. Equipment management involves purchasing the equipment, issuing the equipment, and keeping records on the equipment. Just a few tips. Order good equipment, with all orders managed by one person. There should only be one person in your division that is ordering all of the equipment. You shouldn't have this superintendent buying his equipment and this superintendent buying their equipment. It's more difficult to manage, and it ends up being more expensive that way. Order good equipment. One person is involved in the purchase of that equipment. Usually when you do it this way, you can negotiate reduced prices from your supplier. If you identify a supplier, say, hey, we're going to buy our stuff from you, all of our harnesses we're going to buy from you, what kind of deal can you make us? You're going to get a better deal. All equipment should pass through a single office. There should be an ID number assigned to each harness, each lanyard, and each portable anchorage device. Each component of the system should have an ID number. There should be records of when that device went into storage. The harnesses, lanyards, they have expiration dates on them. The expiration dates generally, or time doesn't usually start counting against the expiration date until it comes out of storage and goes into service. The time in storage doesn't count against the expiration date. So you want a record of the storage date and a record of when the device went into service. The equipment should be issued to employees, and there should be a record of which employee received the equipment. Again, each worker is going to have their own equipment. You should also provide them with a bag to keep all of their equipment, all their stuff in. Keep it secure, keep it together, and protect it from the elements. There's nothing that irritates me more than see a harness thrown in the mud. The bag or some other device you provide to them can help prevent the harnesses being in the mud or the lanyards being left out in the rain, those types of things. Expensive equipment, we need to take care of it. Sun damage is probably just as harmful as anything else. Sun damage can shorten the life expectancy of any synthetic materials. But there's really a lot more to this, and I hope a takeaway that you'll have from this little discussion or the discussion of this slide is that we need to be involved in managing this. It's not just telling workers when they're doing it wrong or telling workers how to do it right. We're also managers that's going to be involved in purchasing and trying to save the company money with our purchasing practices and with our record-keeping practices. The record-keeping side of it is essential also because of inspections. We have to do periodic inspections on the fall protection equipment, and we need to have inspections that are documented. Once the equipment comes into this single office, it's issued an ID number, we record the storage date, we issue it to employees, and we record the date that it was issued, and then we will have a record for that piece of equipment that we will continue to use throughout different phases of the inspection process and throughout the life cycle of that piece of equipment. Hopefully you're getting this. I feel like I'm probably making it more complicated than it should be, but I just want to emphasize the importance of this aspect of safety management. Equipment maintenance, proper storage, inspected daily. The documented inspection needs to be quarterly. Some things to look for when we inspect equipment. The webbing. Look for tears, stitches that are loose, cuts, snags, oil stains, burn marks. Any defects in the hardware, any cracks, snap hooks that don't work properly, any bent hardware. Inspect the anchor points as well. Will the anchor points that the worker is using to tie off to, will it support the weight of an F-150 or a Chevy 1500 pickup? They're about 5,000 pounds. If something appears sketchy or appears like it could fail, don't risk it. Take it out of service. If you see a harness or a lanyard that has what appears to be a defect in the webbing, take it out of service, get it fixed. Get them the good equipment that's going to protect them. One other thing I should mention, we haven't addressed this. If any fall protection gear is ever involved in a fall incident, it must be taken out of service. You can't continue to use it after it's been involved in a fall. The harness should be taken out of service. The lanyard should be taken out of service. And some anchorage points, but certainly the harness and the lanyard can't be used. It should be sent back to the manufacturer for inspection. You send it back to the manufacturer and say, here's what happened. Can you look at it to see if it's been damaged? There are companies out there that if their equipment is involved in a fall and the worker was not injured, they will replace the equipment that was used in the fall with new equipment. All you have to do is send it back to them and tell them what happened, and they will give you a whole new rig to replace what the worker was wearing. which is kind of cool. Not all companies will do that, but some out there will. All right, it's a good thing we're getting to the end because I'm losing my voice and I'm starting to get incoherent, I believe. Been a long unit. This is the 10th video, but it's a very important unit. Throughout your careers in safety management, you'll always be talking about falls, fall prevention, and fall protection. I don't care if you're in agriculture, manufacturing, construction, the entertainment industry. Falls are everywhere. And as safety professionals, it's a big thing on our to-do list is preventing falls or protecting workers if they do fall. So pretty much already said that. It's in every industry. Second leading killer of workers. And these are some of our responsibilities that we're going to have in every industry. Fall hazard analysis, training, design, installation, inspection, maintenance of protective systems, purchasing fall protection equipment, motivating management to invest in fall protection equipment, motivating workers to respect the danger and use the systems that will protect them. And it's a big deal. Yeah, it's not the only big deal in safety management, but it's one of the bigger deals out there. Let me know if you have any questions. I'm going to go ahead and sign out. I will see you in the next unit.